Hey there, James Madison University Physics 140L. I just wanted to talk to you a little bit about the energy lab that we have coming up. Our lab manual has instructions starting on page 30 for a lab called Equality Before the Law. And your goal in this lab, the conservation of energy is one of the fundamental notions of physics, and your goal in this lab is to demonstrate that conservation of energy for some system consisting of two different types of energy at two different times. On page 33 in this lab, you'll see multiple equations for various types of energy, which is especially useful if you are in one of the lecture sections that hasn't gotten very far into energy yet. We present these three questions in the lab manual. What is the initial energy of your system? What is the final energy of your system? And are the two energies equal? Our lab manual explains how an experiment like this was done in one historic experiment, and we're going to encourage you to devise an experiment with some simpler equipment in our lab room. So you'll be writing your own procedure. In a typical semester, this energy lab comes after you've done several labs in person with us, using the equipment here at JMU and learning how it all works. And since we haven't had that opportunity, I just want to note a couple of items you could use other than the force sensor that you had a chance to learn about during the buoyancy lab. Of course, in our lab, we have meter sticks and stopwatches. We also have a motion detector that I will quickly demonstrate here so you can understand how it works. This is a piece of lab equipment that is called a motion sensor, and I have this video here. It's accidentally slow motion, but I think it'll be fine. The way this thing operates is on echolocation. You point this thing at it and it tells you how far away something is. The gold disc makes little clicking sounds, so the clicking sounds go out to the object and then they come back to the gold disc, and the computer can tell you how far away the object is that the gold disc is pointing at. It's just like sonar or the echolocation that bats use to navigate. As a rangefinder, this little device is okay, but its real value is that it can do this continuously, multiple times per second. It can tell me how far away an object is now, and now, and now, and now, which means I can create that into a data table with multiple times, and then I can make a graph from that data table. So for example, I put the sensor at the end of a track here, and I pushed a cart away from it, and then something happened off screen and the cart came back and actually crashed into my motion sensor. You're not supposed to let it do that. The graph of that little experiment that the motion detector made looks like this. So just as an example, we see here the graph of position versus time that the motion detector and computer made for that little motion in the previous video. You can get that detector to graph position or velocity or acceleration as functions of time for one-dimensional motion. So this may be useful to you, or you may try to come up with a different type of setup with different equipment. To be clear, you will have access to tracks like in the video that do have centimeter marks laid out on them, and you'll have access to ways to measure whether or not the track is level or exactly what angle it might be inclined to. We also have access to weights and strings and this box of pulleys, which may inspire you in some way. I mean, I think it's pretty inspiring. We also have things like this box of tennis balls. It looks like there's a racquetball and some table tennis balls and things like that. Items just to maybe drop, roll, bounce, or whatever. So we're trying to get you to do something that's pretty simple in terms of equipment. And what we're hoping is that you can determine the energy at two different times of your simple system of something like a tennis ball and possibly a track. We do also have access to these carts like in the video I had earlier. We can get these out and that's not a problem. These also have a device. You can see I've put this little clear plastic device in it that has these black stripes, and the point of putting that on there is it makes the cart readable to something called a photogate. A photogate is a sensor that detects things that are passing through the gate. So it measures the time that the gate is blocked or unblocked. You can see the little red flashing light on top is indicating when those little black stripes are blocking or unblocking an invisible beam that's cutting across here. So it's able to very accurately measure the time that it is blocked and is not blocked, and therefore we're able to use it to graph or the speed or the rate of change of speed of an object passing through the gate. So if you want to use something like that, that's certainly accessible, and your instructor can help you set that up and use it if you'd like to use it. To be clear, the idea is to have a simple system of equipment that is first in one state and then later is in another state, and you want to be able to measure various things like distance, height, mass, volume, speed, maybe force, maybe temperature, I don't know, so that you can calculate different types of mechanical energy at two different times, and you can compare them and talk about how well they match, which should be perfectly in an ideal world, but of course is not likely to be perfect for our actual experiment. And the whole purpose of this video is to emphasize we do understand this semester is different from most semesters. We are very aware of that. And so your familiarity with the equipment may be less, and I just don't want you to be stressed out about that. I'd like you to take a look at those equations of the different types of mechanical energy and get some idea of what type of energy might be easy for you to measure. Please don't stress out. Ask us if you have questions or need help.